Hi, my name is Amir. In this project, I'll walk you through an agrivoltaics-based machine learning system and the implications of human factors in the development of our machine learning-based system that we are developing here at AgriLight. AgriLight is a startup company that is operating under the agrivoltaics domain, which I will explain shortly what it's all about. Okay, so let's start with the domain first. Agrivoltaics basically allows the operation of solar panels above agriculture, which is not an easy task by itself, as the main challenge is overshading, and it can basically harm the crop yield and the quality of crops, that overshading. And at AgriLight, we've developed a unique dual axis agrivoltaic design, or in other words, we have two movements of the solar panels. As the first one, we can move it both horizontally, which means from side to side above the crop row. And the second movement is tilt axis, where we can basically track the sun, follow the sun to generate more solar power. So this combination of moving the panels from side to side above the tree lines and also tilt movement to follow the sun allows us to control the shade placement based on sensors and real-time machine learning models. And this gives us the understanding of what the plant needs in every minute, light or shade. And also we can generate more solar power on the same land. So as we all know, agriculture is quite a complex environment as conditions change fast. And there are dozens of both environmental and plant parameters that are correlating with each other in every moment. And manual decision-making is quite challenging, to say the least. The human brain cannot really and effectively deal with dozens of different parameters and their combinations and correlations. For example, let's say the combination of temperature, leaf temperature, precipitation, soil moisture, soil salinity, pH of the soil, radiation, leaf temperature, and many other crop health indexes. So in this presentation, I'm going to show how machine learning can support the grower and how the UX should work, and also the privacy and ethical issues that we need to handle with. So the core task is quite simple to describe, but harder to do. We basically need to decide if the crop needs shade or light in every moment. Farmers look at many signals. As I said before, they can track everything in real time. The insight is that machine learning should simplify eventually and not to complicate the task. And also, machine learning should give us higher accuracy of the plant real-time status and real-time needs. So the flow here must be quick, intuitive, but always under user control, which is the farmer in this case. Okay, the user experience is quite simple. The grower enters basic farm details once, and sensors feed real-time data from the field automatically. The dashboard then shows the recommendations, why it was made, and with what confidence. So the grower stays in control. They can override or confirm suggestions, and their feedback helps the model to learn and improve under machine learning supervised models that we develop and run. Now, to inspire trust, the tool must show why it recommends shade or light instead of hiding the logic and do all the calculation inside a black box and to show only the output. we show the main signals that drove the predictions. We also communicate the uncertainty, for example, medium confidence, or give a specific number of percentage of certainty, for example, because farmers need to know how strongly the system feels about its suggestion. Farmers are not the easiest users. They have their own needs and their own habits. Most of them are not super technological. So, and they have been growing their crops for over many, many years. And we need to be very careful with how we present the models. So they need to be our partner design, especially the early adopters. So bottom line, many farmers need to know how strongly the system feels about its suggestion, as eventually this is a decision support tool for the farmers. So they need to be, and they will be, part of the loop. Now, from a privacy standpoint, we don't collect, of course, any personal health or identity data, but we do collect farm location, yields, and behavior, and it counts as sensitive operational and commercial data. So we must comply with GDPR for EU customers, with Israeli law, and possibly with CCPA and other local regulations. This means clear consent, data minimization, also encryption. We use cloud services, so it will be encrypted on the cloud, and also on premise, and of course, allowing users to delete their data as well. Now, ethically, the biggest risks are bias and uneven performance. A model trained in Israel may not work well in Spain or in the US. Also, some wine grapes, for example, some wine grapes varieties may get better predictions than others, or some are more sensitive to sun than others, or vice versa. Now, we handle this with a human in the loop, with override control, transparency, and clear logs. Fairness means making sure that all farmers get the same level of accuracy eventually. Now, to close things up, I walked through the task, the UX, and the privacy and ethical issues. This tool is meant to support the grower, not to automate their job. And with good transparency and careful design, machine learning can really help here to manage climate stress and to improve yields while keeping the user fully in control. Thank you.